Next example. Two lines. X by 2 is equal to y by 3 is equal to z by 4. And x minus 2 upon 2 is equal to y minus 3 upon 3 is equal to z minus 4 upon 4 are. So equations of two lines, they are in Cartesian form, and we have to find whether these lines are intersecting, parallel, skew lines or coincident lines. We can find angle between two lines. If angle between two lines 0, then lines are either parallel or coincident. If angle between them not equal to 0, then lines are intersecting. To find angle between two lines, we should know direction ratios of two lines. Here numbers in denominator, they are direction ratios of two lines. Here we need not find angle between two lines because direction ratios of two lines are same. As direction ratios of two lines are same, means they are either parallel to each other or they coincide with each other. So here two options are remaining. Either they are parallel or coincident. Option B or option D. To verify that, observe first line. Numerator x minus 0, y minus 0, z minus 0. It means that this is a line which passes through point. Suppose it is point E. Then its coordinates 0, 0, 0. So this is a line which is passing through origin. For origin, all the three coordinates are 0. Observe this line. We get coordinates of point on this line from numerator. Suppose it is point B. Its coordinates 2, 3, 4. If both the lines are passing through these 2 points, then lines are coincident. Otherwise, they are parallel. Now it is more convenient to verify whether coordinates of point are satisfied by equation of line or not. Now this is a point on this line, so we need not verify whether coordinates satisfy equation of line or not. These coordinates should satisfy equation of the line. Consider point B. Put x equal to 2, y equal to 3, z equal to 4 in equation of first line. Then we get 2 by 2, 3 by 3, 4 by 4. 1. They are equal. It means that coordinates of point B satisfy equation of this line. So point B lies on first line. Now for second line, we need not verify coordinates of point B because point B lies on this line. So coordinates of point B will satisfy equation of second line. Let us see whether coordinates of point A satisfy equation of second line or not. For that, put x equal to 0, y equal to 0, z equal to 0 in equation of second line. 0 minus 2 upon 0 minus 3 upon 0 minus 4 upon 4. Ratio negative, 2 gets cancelled. Minus 1, minus 1, minus 1. It means that point A satisfies equation of second line. It means that these are the two lines which are passing through points A and B, and passing through 2 points, there is only one line. Only one line can pass through 2 given points. It means that these two lines, they are coincident. They are not pair. So here answer is option D. Next example. Which of the following triplet can be direction cosines of a line? In each option, 3 numbers are given. Triplet of 3 numbers is given. And we have to verify which triplet can be direction cosines of a line. Now, direction cosines of a line satisfy condition. Sum of squares of direction cosines of a line is equal to 1. If L, M, N are direction cosines of line, then L square plus M square plus N square equal to 1. If cos alpha, cos beta, cos gamma, they are direction cosines of a line, then cos square alpha plus cos square beta plus cos square gamma equal to 1. If sum of squares of 3 numbers is equal to 1, then they can be direction cosines of a line. Consider option A. Square each number and find their sum. 1 by 3 square, 1 by 2 by 3 square, 2 square 4, 3 square 9. Square of negative quantity is positive, 1 square 1, 3 square 9. Addition of 3 ratios where denominators same, so LCM 9. As denominators are same, simply add numerators. 6 by 9, 2 by 3. We are interested whether sum of squares of 3 numbers in a triplet is equal to 1 or not. Here it is not equal to 1. So option A not right. If in option A we get sum of squares equal to 1, then we need not verify other options. In that case, answer becomes option A. But here option A does not satisfy required condition. Option B. Square each number. 1 square 1. Root 5 square 5 plus 2 square 4 by 5 plus 1 by 5. Denominator 5. Add numerators. 1 plus 4, 5 plus 1, 6. This is also not equal to 1. Option B not right. Option C. Find sum of squares of 3 numbers. 9 by 7 plus 1 by 7 plus 16 by 7. LCM 7. 9 plus 1, 10 plus 16, 26. Not equal to 1. As first 3 options are not correct, answer is option D. So in exam, we need not verify remaining 4th option. We can directly write answer. But here, let us verify. 9 by 50 plus 16 by 50 plus 25 by 50. LCM 50 because denominators are same. Add numerators. 9 plus 16, 25. 25 plus 25, 50. 50 by 50, 1. So here, answer is option D. Next example. The direction cosines of a line 3x minus 1 is equal to 2y minus 3 is equal to 4z minus 1. and in the options direction cosines are given. Now given equation, it is not in required form, because general equation of line in Cartesian form, it should be x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. So coefficients of x, y, z, they should be equal to 1. Here they are not equal to 1. So we shall make them equal to 1. For that, in these two terms, we shall take 3 common in bracket. X minus 1 by 3 is equal to, here take 2 common in bracket, y minus 3 by 2, take 4 common, z minus 1 by 4. Now we want numbers in denominator. So whatever numbers are present outside bracket, we have to cancel them. So we have to divide equation by a number. For that, we have to take LCM of these 3 numbers, 3, 2 and 4. 3 prime number, 2 also prime number, 4 its factors, 2 into 2. So here to divide equation, 3, 2 and 4 should get cancelled. For that, we shall divide equation by 12. X minus 1 by 3 by 12, so 4 is remaining. Y minus 3 by 2 upon 6 equal to Z minus 1 by 4 divided by 3. If we know direction ratios of a line, then we can write equation of line. Similarly, if we know direction cosines of a line, then also we can write equation of line in Cartesian form. Here numbers in denominator 4, 6, 3. They cannot be direction cosines, because sum of squares of direction cosines, it is always equal to 1. Means each direction cosine, it should be less than or equal to 1. It cannot be greater than 1. It means that these numbers, they are direction ratios of line. Now after direction ratios of line, we can find direction cosines. A 4, B 6, C 3. Direction cosines LMN, L A upon under root A square plus B square plus C square. So it is convenient to find under root A square plus B square plus C square. In this example, it is necessary to find this value. In 3 options, in denominator only one number is there, root 61. But option D is there, none of these. Due to this option, we have to find this value. So under root 4 square 16, 6 square 36, 3 square 9, root 61. Then direction cosines A upon root 61, so 4 by root 61. B 6 by root 61, denominator same, 3 by root 60. Here answer is option